It's something we all do, probably 100 times a day, and we never even think about it. We type a website into our browser, hit enter, and poof, it's just there. It feels like magic, right? Well, behind that one simple click is an absolutely epic journey, a high-speed race across the entire globe. And today, we're going to follow along.
So, let's set this scene. You're there, you type google.com, your finger hits that enter key, and bam! The clock starts ticking. In the tiny sliver of a second before that page pops up on your screen, an entire adventure unfolds. So, let's do it. Let's trace the path of your request all the way from your keyboard to Google's servers and back again. Every great story needs a hero, right? Well, in our story, the hero is this tiny, invisible messenger, a little bundle of information that's about to carry your command across the digital universe. This is where it all kicks off.
The second you hit enter, your computer gets to work. It takes your simple request for google.com and packages it all up. Seriously, think of it like folding a letter and sealing it in an envelope. This digital envelope, that's our hero, the data packet. It's got everything it needs for the trip, the destination, a return address, and your message tucked safely inside.
Okay, so our packet is ready to go, but it hits its first snag. It knows the name of where it's going, google.com, but it has no idea what the actual physical address is. It needs a map. And to get that map, it has to go on its first little side quest, the DNS quest.
So, what is DNS? Well, the easiest way to think about it is that the domain name system is literally the phone book for the entire internet. We humans, we're good with names like google.com. Computers, not so much. They speak in numbers. DNS is that crucial translator that connects the name we type to the number the network actually needs to work.
And this is exactly what that translation looks like. On the left, you've got the name we all know and love. On the right, you have its IP address, the unique string of numbers that tells the internet exactly where that server lives. I mean, can you imagine if we had to memorize that string of numbers for every website we visit? No way. Thank goodness for DNS.
Now, your computer is pretty smart about this. It doesn't just immediately shout out to the whole internet for help. First, it checks its own memory, kind of like checking its pockets. That's the browser cache. If it's not there, it asks the operating system. Still no luck? Okay, it'll ask your internet service provider. It's only if none of those nearby sources know the answer that it goes all the way up the chain to the internet's big official root servers. It's this whole cascading series of questions, all designed to get the answer as quickly and efficiently as possible.
All right, mission accomplished. Our packet has the IP address for Google's server. It has the map. But its first real challenge is actually a lot closer to home. It's just getting out of your house. It has to navigate your local network first.
To really get this part, you gotta understand that there are two kinds of addresses at play here. The IP address, that's like the mailing address for your house. It tells everyone where your network is located. But the MAC address, that's more like the specific name of a person inside that house. It's a permanent, unique ID burned right into your laptop's hardware.
So your laptop knows it has to get the packet to your router to get it out to the world. It knows the router's local IP address, but to make the actual physical handoff, it needs that MAC address. To find it, it uses something called ARP, which is basically your laptop just shouting to all the other devices on your Wi-Fi, "Hey, who's got this IP address?" Your router hears the call and says, "Yo, that's me. Here's my MAC address." It's so simple and so brilliant.
And this shows us something really, really important about how our packet is addressed. You can think of it in layers. The Layer 3 IP address is the final, ultimate destination. That's Google's server. That's not going to change for the whole trip. But the Layer 2 MAC address, that's just the very next step. For this first hop, the destination is just your home router. And with that, our packet has been successfully handed off to the router. It's made it to the digital front door. Now it leaves the safety of your cozy home network and heads out onto the wild, vast, global superhighway of the internet.
Right as the packet leaves, your router does this really clever little trick called NAT. Think of your router as the receptionist in an apartment building. All your devices, your laptop, your phone, your smart TV, they all have private room numbers. But to the outside world, they all share one single public street address. NAT swaps your laptop's private address for that public one, and it keeps a little note so it knows exactly which device to give the reply to when it comes back. It's a fantastic system for security and for saving addresses.
The thing is, the internet isn't one big road. It's this unbelievably complex web of connected networks. Our packet has to travel this web by hopping from one router to the next, and at each stop, that router makes a split-second decision about the best path to send our packet on next to get it just a little bit closer to Google. And here is the absolute key to this whole journey. At every single hop, the final destination, that Layer 3 IP address for Google, it never, ever changes. But the local next hop delivery address, that Layer 2 MAC address, it changes constantly. It's this continuous physical handoff from router to router to router all across the world.
Now, to make this trip even faster, the huge networks that form the backbone of the internet use cool technologies like MPLS. You can think of it like a special express lane on the highway or a high-speed bullet train for data. Instead of having to check the full map at every single stop, packets with an MPLS label get put on this predetermined super-fast path, just rocketing them toward their destination. After hopping across cities, countries, maybe even under oceans through fiber optic cables, our data packet has finally arrived. Its mission, though, is only halfway done. It delivered the message, and now it's got to bring the answer all the way back home.
And success! Touchdown! Google's server gets the packet. It reads the request, sees you want the homepage, and instantly gets to work grabbing all the data needed to build it. Then it bundles all of that up into brand new packets, addresses them back to you, and sends them on their way.
So what's actually in that return package? Well, you can think of it as the blueprints for the website. You've got HTML, which is the raw structure, the skeleton of the page. You've got CSS, which is all the visual style, the paint, the furniture, the design. And you've got JavaScript, which is the magic that brings it all to life, making it interactive.
And here it is, the most mind-blowing part of this whole thing. That entire round trip, the DNS lookup, navigating your home, hopping across the entire planet, the server doing its work, and the full journey back, all of it can happen in about 50 milliseconds. That is literally faster than you can blink. It's just incredible.
So the next time you load a web page, just for a second, think about that unbelievable, invisible dance of technology that's making it all possible. We just followed the path of one tiny packet. Now try to imagine a billion of those journeys happening at the same time all over the world every single second. That is the true scale and the true magic of the internet.